Earlier in the course, we talked about ancient numeration systems, right? And we talked about Roman numeration systems and Mayan numeration systems and Babylonian numeration systems and the different bases that went along with them. I'm curious if you remember, if you recall, what the base system that was used in Babylonian times, Babylonian numeration system was. It was base 60. And we still utilize base 60 in a lot of the things we do today, particularly in geometry. And so we're going to talk about angle measurements now. Here is a circle. And the ancient Babylonians devised a method for measuring angles. And again, we talked about angles in the last video. Here's the angle and how big that measurement is compared to, say, this one, or say, this one. And so how do we number that? How do we assign a number to our angles? We do it with degrees. And what they did was they took a circle and they cut it up into 360 equal parts. And those parts are called degrees. And so if you imagine a line extending right over here to 0, and then another line extending right next to it to that very first line right here. So you had one line coming here and another line coming there. That distance there is called 1 degree. We often abbreviate it in degrees. And so that is how a circle is divided up. And so when we say something is 10 degrees or 30 degrees or 90 degrees, that's how we measure it. And we'll talk more about how we do that later. Now, sometimes, depending on what we're measuring, we need to even measure more accurately than just by degree. So each degree, if you think about, again, the Babylonian system was base 60. 60 times 6 is 360. So that's a common measurement there. But picture this small little segment there. They also break that up into 60 parts. So if we take that 1 degree cut into, can't write, 60 equal parts, those are called minutes. So a minute is a 60th of 1 degree, kind of like how our time is divided into minutes and hours. And then, so imagine this little thing cut up into 60 equal parts. That's a very, very, very small fraction. And then minutes can also be divided into 60 parts each, called, you guessed it, seconds. So I'll just copy and paste it so it's nice and neat for you. So each degree can be divided into 60 equal parts called minutes, and each minute cut into 60 parts called seconds. And again, that's where we get our hours and minutes and seconds from. So how do we measure degrees if we're, again, looking at something that looks like that, right? An angle on our paper. We use a protractor. And so a protractor, how did the mathematician plow his field? With a protractor. One of my worst math jokes. And so what is it? What is a protractor? It is this device right here. And so how do we use it? Well, if you have a line or an angle like this, two rays going off in those directions, there's usually a small little hole right there that you would line up the vertex with. So you'd always put your vertex here. You would make sure one of the lines is at 0, and then you follow where does the other line hit the edge of the protractor, 60. So we know that that is a 60-degree angle. And so angle B in this case is 60 degrees. We can also use a circular protractor if necessary, like this. We saw this earlier. When our angles are more than 180 degrees, because if I scroll back up, notice one side of your protractor only goes to 180 degrees, which is a straight line. But if you have to go with an angle bigger than that, all the way over there, again, you start the same way, and then you line it up, and here it would be 220 degrees, right? So angle DEF is 220 degrees. That's how we measure our circles. Now, I'm sorry, angles. That's how we measure our angles. Now, there are a number of different types of angles. And let's take a moment to discuss each of these. You will need to know these names for sure. So think about our protractor. And if we have an angle that goes straight to the right and straight up, it is 90 degrees, exactly 90 degrees. We call that a right angle. You probably heard that before. So a right angle is perfectly 90 degrees. If we measure our angle and it's less than 90 degrees, it is called acute. It's small, it's little, it's acute. If it is bigger than 90 degrees, but less than 180 degrees, so it is, I'll say that's our angle X is greater than 90 degrees, but less than 180 degrees. It's between those two. Then it is called obtuse. If it is greater than 180 degrees, as we talked about earlier, it's called a reflex angle. So you'll need to know those terms for sure, are different types of angles. Now, all the angles that we've looked at so far have just been made up of two rays. We had a vertex, we had a ray going in one direction, a ray going in the other direction, and we looked at this sort of angle. A lot of the times, we are looking at angles made up of multiple rays. And so specifically, we are often looking at angles that are made up of multiple rays, but one of them is a 90-degree angle. So do we notice how we have that right angle right there? So this line and this line make a right angle, but then we have this other one going off in this direction, splitting it into two parts. So when we have two angles that combine to make a 90-degree angle, we say that those angles are complementary. Complementary. Complementary things make up a whole, right? If something complements something else, it goes together with that thing. And so complementary angles make a whole right angle, 90 degrees. They always add up to 90 degrees. So we could say the measure of angle 1 plus the measure of angle 2 must equal 90 degrees. If we add those two numbers together, they would equal 90. This is not a right angle. This is actually a straight angle, right? It's 180 degrees. Angle 3 and 4, if we add them together, adds up to 180 degrees. And two angles that do that are called supplementary. Again, these are words and terms you will definitely need to know. So they share angles that share this common side, right? Angle 1 and angle 2 both share that side. Angle 3 and angle 4 both share that side. Another thing about certain angles is that they can be right next to each other, like these were, but any two angles that share a common side are called adjacent angles. Adjacent angles. They don't have to be complementary or supplementary, but they just have to share a common side and not overlap. So we could make a drawing like this. And let me add some labels to it. So we will say we have A and B and C and D. And this is a case where we can't just say angle B because we have two different angles that use that vertex. And so we could say that A, B, C, which is this angle, and angle CBD, which is this angle, those are adjacent. Because again, they share this common side of C, and they don't overlap, and they have this same vertex. They have that same vertex. And so what I want to show you here is a little activity for us to examine. So if you have paper out that you want to do this with, because sometimes it can be good to have something in your hands to do this, we have two pictures, right? Two different pieces of paper. And the first one, if you have a piece of paper, again, just make a fold that kind of looks like that. And then label these angles 1, 2, 3, and 4. And then on a separate sheet of paper, right from the corner of your paper, make a fold over to there. And we'll label that as 5 and 6. Once you've done that, what we're going to do is we're going to identify each of the following angles or pair of angles by the numbers in the diagrams. Okay? So we're going to look at acute angles. So really what we're doing is just saying which of those angles that you see there are acute. And do you remember what acute means? And then which of these angles are obtuse, right? And it might be more than one. So take a moment and see if you can answer all those questions based on all 6 of these angles. So we'll start with number 1. So number 1 asks which angles are acute. Well, remember, acute means that it's less than 90 degrees. So I would, as I'm looking at this, I see that number 1 is less than 90 degrees. So angle 1 and angle 4 is also less than 90 degrees. 2 and 3 are not, but 5 and 6 are also less than 90 degrees. Number 2, obtuse. What does obtuse mean? It means it's bigger than 90 degrees, but it's less than 180 degrees. We've got 2 of those. Angles 2 and 3 are both obtuse. Number 3 says supplementary angles. So supplementary angles are angles that add up to be 180 degrees. Or they, when you combine them, they would go all the way to a straight flat line. 1 and 2, so angles 1 and 2 are supplementary, and so are angles 3 and 4. They combine to make a straight line. So angles 3 and 4. Number 4, complementary angles. Angle 5 and 6, again, they exist at this right angle here. And so angle 5 and 6 are complementary. And then 5, it asks for adjacent angles. We have 3 pairs of those. 1 and 2, angles 1 and 2 are adjacent. Angles 3 and 4, and angles 5 and 6 are adjacent. So hopefully that task helped you start to see that, how to examine a geometric figure. So now let's move into the next part of these different types of angles when we have lines that are going to intersect. So here's a drawing, and take a moment and just examine it. We'll talk about what each of these things represent. What we have here are two intersecting lines, right? We have a line here and we have a line there. When we do that, we end up with four pairs of adjacent supplementary angles. 1 and 2 are adjacent and supplementary. 2 and 3 are adjacent and supplementary. 3 and 4 are, and so are 4 and 1. Non-adjacent angles formed by two intersecting lines, meaning 1 and 3 and 2 and 4 have a name. Those are called vertical angles. And vertical angles are always going to have equal measures. So when you have any two lines that crisscross like an X, any two lines that crisscross like an X, lines that are, or the angles that are opposite each other are always going to be equal in measure. Those yellow angles are equal. These green angles are equal. And those are called vertical angles. So again, in our drawing, 1 and 3 were vertical and 2 and 4 were vertical. And that means that their angle measures are exactly the same. The next thing we will discuss is another type of line combination, and it's perpendicular. So if two lines intersect to form right angles, they are called perpendicular. Perpendicular lines meet at a right angle. They're always going to cross like a T, or they'll maybe make an L. Okay. And so we can say that lines M and N is how we're notating them here. Lines M and N are perpendicular, and we use the notation of an upside down T. This says M is perpendicular to N. That's how we state that. Line M is perpendicular to line N. We could also note them as line segments. So we could say that line segment AB, remember how we note a line segment? Remember, the line goes on forever. The line segment just is this section of it from A to B. Line segment AB is perpendicular to line segment CD. That's another way that we could also notate that perpendicular relationship. We often kind of consider the opposite of perpendicular to be parallel. So what do parallel lines look like? They look like this. And again, just like with perpendicular, we have a notation for this. Now, how do we describe parallel lines? Parallel lines are lines that are in a plane, but they do not intersect. So they're on a flat surface, right? So if you use the analogy of your hand, right? Your hand is your flat surface. And if your fingers are all pointing up, two fingers are in the same plane, but they're parallel, right? Those fingers are never going to cross. So they do not intersect. What's the notation for parallel lines? Well, we can say that M is parallel to N. We use two vertical lines, or we can say line segment EF is parallel to line segment GH. And one of the steps up now in our analysis of this is when we take those two parallel lines and we draw a line across them, and we start to examine all of these angles. So our next figure looks like this. So just take a moment to examine this. We have three different lines. We have line L, line M, those are parallel. But then we have this T line going across them. This is called a transversal. So if two lines are intersected by a third, we call that third line a transversal. And something really interesting happens. Note that there are two angles that are identified here. Angle 1 and angle 2. This one and this one. Those have a name. Those are called alternate interior angles. 1 and 2 are called alternate interior angles. And alternate interior angles are always going to have the same measure. They're always going to be equal. It's really pretty interesting fact. And so we know from earlier that these two angles are equal. Recall from up here, vertical angles. Remember vertical angles? So these two angles are vertical. These two angles are alternate interior. They're on alternating sides. They're both on the inside. And these two angles are also equal because they are vertical angles. And so when we have parallel lines and we draw a line across them, we end up with 1, 2, 3, 4 angles, a set of 4 angles, and they're all equal to each other. The measure of them is all equal. And so we'll finish this video by doing one final little activity. Take a piece of paper and just fold it in a few different ways, or maybe take several different papers. Fold it one way to show parallel lines. Take another piece of paper, fold it to model that alternate interior angles have the same measure, and then fold it to demonstrate perpendicular lines. So I did get a few pieces of paper here to model this, right? So parallel lines, we might take our paper and we fold it once this way, then maybe we take it and we fold it again the same way. And you can see how this is great for young learners, right? So they're enjoying folding their paper, and what they get here are these two parallel lines. Maybe they even take a pen or pencil and trace them in, right? So then they get the experience of making the lines appear and then also drawing them in. Now, with the second question, it said alternate interior angles having the same measure. So again, we have our parallel lines already started. So maybe we take our paper this way and we can really fold it whichever way we want. I'm just going to fold mine like this. Pick a random angle to fold it at, unfold it, and what we're going to see here is this new line that appeared across them. And again, we can see then that, use a highlighter, that this section right there, again, is going to be the same as that section right there. Those are alternate interior angles. And then lastly, we might do perpendicular lines, right? You might have your students do a hot dog fold first. Or I guess that's a hamburger fold, isn't it? So they fold it that way, and then they rotate it, and then they do the hot dog fold, right? So that as long as you are making those nice and straight and even, folding it both ways, then you can see we get our intersecting perpendicular lines. And so again, that tactile experience of doing that folding the lines is really important for helping cement those concepts.